so in this one we're going to look at graphing parabolas. So parabolas are the shape that you get when you graph quadratics. We know what quadratics are. Quadratics are anything with an x squared. Well, where the highest degree or exponent is x squared. Alright, and we know how to graph a little bit. We did it back in, well, solving for system of equations. We graph lines. So we're going to go ahead and use some of those ideas. And one of the ways that we graph lines was we found the intercepts. We knew that we could graph stuff by plotting points. So we found the intercepts because they were easy points to find. So let's go ahead again and find the intercepts. So if I find x-intercept, that means I'm going to let y equals 0. Intercepts are the same thing as zeros. So I'm going to get 0 equals x squared minus 4x minus 5. It's quadratic, equals 0, so I know I can factor it. X minus 5, x plus 1 equals 0, x equals 5, and negative 1. So this means I have 2 points. I have 2 points where my x-coordinate is 5, my y-coordinate is 0, since I subbed in 0 for y. And I have another point, x is negative 1, y is 0. I can go ahead and throw them on my graph. 1, 2, 3, 4, 5. So 5, 0, minus 1 is 0. Okay, so I got 2 points already. With the line, we only need 2 points, but with quadratic, this is going to be a curve. Anything that's not a line is curve. So I'm going to have to find more than 2 points to see if I can find the relationship. So let's find the other intercept. So y-intercept, I'm going to let x equal 0. So I'm going to get y equals 0 squared minus 4 times 0 minus 5. So y equals negative 5. So I have another point. X is 0 this time. Y is negative 5. I can put that in my graph. And right now, if I look at it, my graph kind of looks like a V. It looks like, or check mark maybe, I'm not really sure. So let's find a few more points to see if I can get a better idea of how this thing moves. So let's try stuff to both sides of my x-intercepts and see what happens. So let's try something like negative 2. So I'm going to just plot a few points here. I'm going to put some things in for x and see what I get for y. So if I do negative 2, I'm going to get negative 2 squared is 4, plus 8 is 12, minus 5 is 7, so I'll get 7. So it shoots up pretty fast. If I do negative 3, I would get 9, plus 12 would be 21, minus 5 would be 16, so it's going to shoot up even more. So I can now get an idea that the more to negative, it's just going to get higher. So I got an idea on that. So let's do higher on the other side of my intercept, my 5. So let's try 6. If I do 6, I'm going to get 32 minus 24, 8, I think. 6 squared, that's 36. Oh my god, 36 minus 24, 12, minus 5 is 7. Oh, so 6 is at the same exact space that negative 2 was. If I put in 7, I'll learn it's at the same exact space that the negative 3 was. So right now I got some patterns going on here. Let's try in between my intercepts. I already know what happens if I put in 0. If I put in 0, I got negative 5 down there. So let's try 1, 2, 3, or 4. So go over here so I can continue my little table. So if I put in 1, I'll get 1 squared is 1, minus 4 is negative 3, minus 5 is negative 8. So 1, negative 8. So that'd be 5, 6, 7, 8, so right there. If I put in 2, I'll get 2 squared is 4, minus 8 is negative 4, minus 5 is negative 9. Oh, so it's not going down as fast as it was going up. So I'll get 2, 9. If I put in 3, I should get 9, minus 12 is negative 3, minus 5 is negative 8. So again, I got kind of a pattern going on here. Got same y value again. If I put in 4, I'll find out that I actually should get negative 5. So this, by just plotting points, is what my graph looks like. So my graph looks like a U. I'm just going to draw it from the bottommost point since we see that it does have a turnaround. And it's a U where I keep hitting the exact same y values on each side, which I guess would make it a U. What this means is that this is symmetrical. So it's symmetrical through this line. everyone hopefully knows what symmetrical means. Symmetrical means same on both sides. So around this line, it's symmetrical. We actually call that line something. We call that line the axis of symmetry. And we can find that when I graph any quadratic, it turns out to be a parabola. Meaning it's always going to be symmetrical, and it's always going to be symmetrical through the middle line. To find that middle line, really, it should be the halfway point between any two corresponding points, meaning any 2 points are on the same level. So between my points where x equals 0, between my point, or y equals 0, between my points where y equaled whatever that was up here, I think it was a 7, between my points where y equaled 16, I should be able to just do the halfway point. If it's symmetrical, that means it's the exact same on both sides. So I should just be able to do the halfway point between them to find out the line where it's symmetrical. Let's check it with the y equals 0, 1, y equals 0, 1. With 5 and negative 1, it was up here. That's where we got our intercepts from. So the halfway point would just be averaging them. So I would get 5 plus negative 1 over 2. So 4 over 2 would just be 2. So I have an axis of symmetry. That goes through where every state that x equals 2. So it's a line. Axis is a line. You have your y-axis, x-axis. Vertical lines are x equals. And this is going to be every x on this line, on this axis, is 2. So it's the line x equals 2. Okay, so there's something more interesting about the axis of symmetry. Is since it's a U, and as I said, every single parabola is either a U or it could actually be an upside down U, that means it has a turnaround point. That turnaround point is always going to lie smack dab in the middle of the graph, really. So that is called something. It's called the vertex. And that x-coordinate of the vertex is your axis of symmetry. It is your middle line. So in this case, 2. To find the y-coordinate of the vertex, to figure out how high up or how high down it lies, you do what we did. You just sub it in and figure out what the y is. That will tell you how high up and how high down. So we actually can graph these a lot easier. We can actually graph these by just finding the x-intercept, the y-intercept, the axis of symmetry, which is the same thing as the x-coordinate of the vertex. If we can just graph those points, we can graph the parabola. So let's try it with this. Y equals x squared plus 8x plus 12. I'm going to start off the same way. I'm going to try to find the x-intercept. So I'm going to let y equal 0. So I'm going to get 0 equals x squared plus 8x plus 12. That is factorable. X plus 6. X plus 2. So x equals negative 6 and negative 2. So again, I got 2 points. I have negative 6, 0, and negative 2, 0. So I'm going to graph them. Negative 2, 0, 3, 4, 5, 6. Wait, 1, 2, 3, 4, 5, 6. Okay, I can count. Negative 6, 0. Okay, I'm going to do my y-intercept. So I'm going to get x equals 0. So I'm going to get y equals 0 squared plus 8 times 0 plus 12. So that's going to be all the way up here. I kind of cheated and drew 12 hash marks originally. So I have those. So I could try to plot a bunch more points, or I could just try to find the midpoint. So if I try to find the midpoint between my x-intercepts, and I can just look at it really and tell that my midpoint is going to be this negative 4. It's the one that's halfway between them. I could average them if I want to. This will be your axis of symmetry, because that's going to be the middle line that it has to be symmetrical about. So I could average them and get negative 6 plus negative 2 over 2, negative 8 over 2. Again, I would get negative 4. So my axis of symmetry is going to equal x equals negative 4. Or is x equals negative 4. And now I need to find out where this turnaround point is. So I know my x-coordinate, I don't know why I just wrote x there, oh well, is negative 4. I need to find out my y. I know that my midpoint is somewhere along this axis of symmetry, somewhere along this line, but I don't know how high up it is, or how far down it is. So I need to figure that out. So I can just sub that back into my original equation. I would get y equals negative 4 squared plus 8 times negative 4 plus 12. So that would be negative 4 squared would be 16 minus 32 would be negative 16 plus 12 would be negative 4. So I actually have negative 4, negative 4. Negative 1, 2, 3, 4. So my vertex actually lies there. And again, I don't have to draw the other points. I can say, okay, so that it's going to hit on my right side through my intercepts. Draw my intercept much bigger so it actually hits it. And it's symmetrical on the other side, so it has to follow the exact same pattern. And that's what my parabola is going to look like. Okay, we'll look at this more in the next section.